Okay, so I have written down my general rules because it's on this page, but we're going to need it for several pages going forward. Write a general recursive and a general explicit rule for each arithmetic sequence. 100, 88, 76, 64. Okay, if I do a little math, 100 minus 88, that's a difference of 12. 88 minus 76, that's a difference of 12. I'm going down by 12 each time, so my common difference is negative 12. Okay, once again, I'm using the general format, so I have to state what my first term is, given that f of 1 is 100, and that the common difference is negative 12. Here's my rule. F of 1 equals 100, and then comma. F of n is equal to the previous term value minus 12 for all n values greater than or equal to 2. Okay, which means basically, hey, we're going to start at 100. Okay, 100 is the first one, and then to get all the rest of them, we say 100 minus 12, whatever that is 88. 88 minus 12 for the third term, so on and so forth. The explicit rule, follow the format. F of n is equal to 100, so I put that first term in there, plus d, and then in parentheses minus 1, but plus d. d this time is plus a minus d, so it's minus 12 because d is a negative value this time. All right, then I have 0, 8, 16, 24, 32. The value of the first term is 0. Common difference is 8. Recursive rule. You state the first value, which is 0 in this case, and then follow the format. Value of the nth term is the value of the previous term plus 8 for all n's greater than or equal to 2. Explicit rule is going to be value of the first term plus 8 n minus 1. Okay. All right, number 6 says, what is the recursive rule for the sequence f of n is equal to 2 plus negative 3 n minus 1, and how do you know? Well, first of all, what they gave you is in the explicit rule format, and if we just break it down, the 2 was the first term value, and the common difference is negative 3 because it's right there where the d goes in the equation. So if I know that the first value is 2 and the common difference is 3, I can use those things and write my recursive rule. Given that the first term is 2, f of n is equal to the previous term value minus 3, and that should say for all n greater than or equal to 2. Okay, so you're just following the format. Write a recursive rule and an explicit rule for the following sequence: 6, 16, 26, 36. Okay, so the common difference is 10, and the first term is 6. The recursive rule, you have to state the first term, and then the nth term is the previous term plus 10 for all n's greater than or equal to 2. That's your recursive rule format. Explicit rule, f of n is equal to first term plus common difference times n minus 1. Okay? Again, we're just using those general formats over and over again. The explicit rule for an arithmetic sequence can be expressed as a function. You can use the graph of the function to write an explicit rule. Okay? So explicit rules are tied to functions, which is what we're learning about. All right, example 3 asks you to write an explicit rule in function notation for each arithmetic sequence. All right, so example 3a, the cost of whitewater rafting depends on the number of passengers. Base fee is 50 and the cost per passenger is 25, and the graph shows the sequence. For one passenger, you're going to pay $75. For two passengers, you're going to pay $100. For 3 passengers, 125. For 4 passengers, 150. Okay? Because you've got a base fee plus 25 per passenger. First, the common difference between consecutive terms, the common difference is 25. And then I also know that the first term is 75. So I use those two things to write an explicit rule. How do I write an explicit rule? I go back to my format because maybe I haven't memorized it yet. Okay, my explicit rule is going to be f of n is equal to f of the function value of the first term plus common difference times n minus 1. So when we put all of our things in there that we know from this particular situation, that is 75 plus 25n minus 1. All right, example B says the number of seats per row in an auditorium depends on which row it is. The first row has 6 seats, the second row has 9 seats, the third row has 12 seats, so on and so forth. And the graph shows the sequence. Here's your table with your position numbers and your terms for the sequence. The common difference each time is a difference of 3. Okay, so your common difference is 3. And your first term is 6. So you can, again, you're following the general explicit rule format. So you're substituting 6 for your first function value and 3 for D. And here's your explicit rule right there. Okay, compare the graph of function f of x is equal to 3 plus 5x minus 1, and the graph of the sequence f of n is equal to 3 plus 5n minus 1. Okay, so this one that I circled in red is an example following the explicit rule. And when I graph the sequence, it is a discrete set of points. Okay? Here, because they haven't stated a domain and range, we can assume that it is all real numbers. And the graph of that function is a line. Now, how are these two things related? Well, all of the points from the explicit rule would be on the line of the function. Okay? All right, number 9, Jerry collects hats. The total number of hats in Jerry's collection depends on how many years he's been collecting hats. After the first year, Jerry had 10 hats. So function value 1 is 10. Each year, he adds the same number of hats to his collection. Well, I go to the graph and I can see from 1 to 2, that's a difference of 8. From 2 to 3, that's a difference of 8. From 3 to 4, that's a difference of 8. So write an explicit rule in function notation for the arithmetic sequence. All right, so it's going to be value 1 plus common difference times n minus 1.